request you needed to send next. So one of the mechanisms for this is message queues. Yeah, we have discussed this in the playlist, so I won't be getting into too much detail. But message queues are nice in the sense that once you give a message to the message queue, it ensures that the message will be sent. Maybe now, maybe 10 seconds later, maybe 15 seconds later. Those are configurable options. And also how many times you're going to retry, all of this is configurable in the message queue. If the message queue fails to send the message even after 5 retries, it can tell you that it's failed. You propagate the failure all the way to the client, saying that, no, I couldn't send this group message. Okay, that's also fine, but the client needs to be told that it's failed or it's cleared. Interestingly, when the group service gets this message, it can send a response that, yes, I got the message. Sessions then sends a response to gateway, and the user who sent the original message gets a sent tick mark. Okay. Group receipts when it comes to delivered or seen is pretty expensive. Main reason being that everyone needs to say, yeah, I got the message, and then finally it has to come back to this guy. So we won't be getting into that. Many chat applications actually don't even have that, so it's fine. Right. The final few interesting things when it comes to chat messaging or group messaging especially is that you need idempotency. There's an entire video I made on retrial and idempotency, again taking the Tinder messaging example. So you can have a look at that for the technical details. This architecture is actually very resilient, and as a chat system, it's going to do pretty well. There's some tips and tricks over here that you can get to know only if you have worked on messaging systems. So I'll give you a few examples. For example, I was just reading this blog that Facebook Messenger does. It deprioritizes messages in case there's a huge event, like let's say New Year's, or let's say some festival like Diwali in India. There's going to be a lot of messages. Everyone's going to be wishing each other Happy Diwali, Happy New Year, and that's going to be putting a lot of load on the system. So all the principles of rate limiting come in here, where you don't take messages which are very important, or sometimes you just drop messages. Instead of dropping, the best thing to do is to deprioritize messages. Things like last seen can be ignored. The entire feature can be ignored. Has this message been delivered? Has it been received? Those are not as important as actually sending the message to the user. The first thing of the server getting the message and the acknowledgement, that's all the user needs to know. Okay, that's more important than seeing whether the person has read the message or not. So by deprioritizing unimportant messages, you're actually keeping the system health good, and you're performing okay instead of not performing at all. And over here, I'd like to make an announcement. There's a collaboration I've done with educator.io. It's on their series for system design. And the thing is, I had already bought the course. So after I did this collaboration, I was like, damn it, I can't get the course for free now. However, the course is really, really nice. Of course, it's on system design, and it explains how things work in these large-scale systems. What I had to do for you guys was to fight with them to get a discount for us. This community is going to be getting a discount of 10% for every person who uses the promo code that I'll be mentioning in the description below. I think it's Gaurav, by the way, but I'll just mention it in the description below. This is a part of the set of courses that educator.io offers. Grokking the System Design Interview is a very famous course. A lot of people before their system design interviews, they go through this course in detail. The best thing about this is that it has a lot of topics when it comes to load balancing or caching, so on and so forth. It's got a lot of those simple topics, and it's got a lot of systems that it has actually designed. So with this, you get hands-on experience on designing systems. The best thing about you going through this channel is that you're going to be getting a discount of 10% for the first 100 users only, though. The link is in the description below. And the reason why I actually partnered with them is because it really goes well with the channel. So with 10% off, the total price will come out to be, right now I'm seeing it's at 49. This video is on the basics of system design. So the problem is not actually load balancing. The problem is adding and removing servers, like we saw. That completely changes the local data that we have in each server, right? And to avoid that, we're going to be using this concept where we are still going to be hashing all the requests according to their IDs, right? Request ID is still there. We still hash request IDs. So what's different? Well, what I'm drawing is a ring. And now I want you to imagine that instead of an array, which can map this hash function value from 0 to m minus 1, this is a ring which contains the positions 0, 1, 2, 3, so on and so forth, up to m minus 1. Right? It goes all the way around, and m minus 1 sticks to 0. So it's a ring of hash. Fine. So, of course, this thing can be mapped into a point over here. Let's say that point is over here. So this request is pointed over here. We are going to have multiple requests. So these are where the requests are. Now, what we can do is we can take the servers, and we actually need to send these requests to those servers. So the servers themselves have IDs, which are from 0, 1, 2, 3, 4. Right? First we had just 4 servers. So these are the server IDs. What I can do is hash these server IDs also using the same hash function. Right? Or a different hash function, it doesn't really matter. What I want to do is then take the remainder with the search space, which is m. So I take the remainder with m. And as an example, if I hash 0 mod m is 30, then let's say h of 0 is 49, mod 30 gives you 19. So server 1 will be hashed to position 19. So let's say that is over here. Right, S1. Similarly, let's say S2 is hashed here. We have S3 here and S4 here. Now, whenever a request comes in to this ring that we have, what we do is we go clockwise. We go clockwise and find the nearest server. This server is going to be serving this request. That's it. Simple algorithm. This one is going to be served by S2. This one is going to be served by S3. Or rather, this one is going to be served by S4, this by S2, this by S3, this by S1. In fact, it goes over here to S1. Okay. So S1 has load of 2 requests. This has load of 1, and a load of 1. Right. So why is this the architecture we are choosing? Because the hashes are uniformly random. You can expect the distance between them to be also uniform. In which case, because the distance is uniform, the load is uniform. The requests are uniform, of course, so they're being mapped to the right places. So the load factor turns out to be, on average, expected 1 by n. That's the smart bit. But you already had that earlier. That's not the problem. The special thing is, now if I lose a server, let's say S1, or let's first add a server, in fact. So I have a 5th server, right, which is mapped onto this point. Where should I add it? Over here, yeah. This is S4. Then any requests which come in here are going to be served by S4. So initially, these 2 requests would be served by S3, which would have a load factor of, let's say, 3. But because of S4, these 2 requests find the nearest clockwise server, which gives S4 the load factor of